Displaying shapes in animation. Before shapes can be displayed in animation on a structure model, the following steps must be carried out. 1. Draw or import a model of the structure. 2. Import measurement data into either a data block or shape table file, or acquire data directly from front-end hardware using an acquisition window. 3. Assign the measurements in the data block, shape table, or acquisition window to DOFs of the structure model. In this tutorial, step 3 will be illustrated by assigning measurements to a structure model and then animating its shapes. During shape animation in a structure window, each point on a structure model is animated by evaluating its animation equations. An animation equation is simply a weighted summation of measurements. If the current animation source has a measurement number that matches the measurement number in an animation equation, data from the measurement number is used to evaluate the equation. Each trace in a data block has a unique measurement number, which is its row number in the traces spreadsheet. In a shape table window, each DOF in the DOF spreadsheet also has a unique measurement number, which is its row number in the DOF spreadsheet. Each DOF on a structure model has one of the following types of animation defined for it. Measured. A DOF with the measured animation equation in a measured direction. Measured equations are created when measurement numbers in an animation source are assigned to DOFs of the structure model. Interpolated. A DOF with an interpolated animation equation is an unmeasured direction. Interpolated equations are created after measured equations have been created by executing draw, animation equations, interpolate. Fixed. A point in direction that will not move during animation. Each point on a structure model has its own measurement axis. These axes should be oriented so their directions are the same as the transducer measurement directions at each point. Each point has one of the following types of measurement axis. Rectangular, with axis directions of X, Y, and Z. Cylindrical, with axis directions of radial, theta, and axial. Spherical axis, with axis directions of radial, theta, and phi. And machine measurement axis, with axis directions of horizontal, vertical, and axial. For this tutorial, we will use the project file car.vtprj located in My Documents, ME'scopeVES folder. This project contains a car body model and a data block file with 4 time domain traces in it. To open the project, execute File, Project, Open in the ME'scopeVES window. The Windows File Open dialog box will open. Select the project file car.vtprj located at My Documents, ME'scopeVES, and press the Open button. Execute Draw, Animate in the Structure window to start sweep animation from the Data Block window. Notice that only 4 corners of the car are animating. These are the points where measurements were made. To examine the measurement axis, execute Animate, Draw in the Structure window to stop the animation. Execute Draw, Animation Equations, Equation Editor to display the Equation Editor tabs above the point spreadsheet. Notice that the first point in the spreadsheet, labeled 1, is selected. Its measurement axes are displayed on the model, and the Measurement Axis tab displays information about the axis. Notice also that Edit, Click Select is enabled so that as you move the mouse pointer over the structure, the measurement axis of the nearest point are also displayed. Only 4 measurements were made on the car. The 4 acquired time domain traces are displayed in the data block window. The 4 measurement points are displayed as bold points on the 4 corners of the model. Hover the mouse pointer over each measurement point to display its measurement axis, and click to select it. After all 4 measurement points of the body are selected, their measurement axis will be displayed. Scroll through the Directions Cosine spreadsheet on the Measurement Axis tab. These are the cosines of each measurement axis with respect to the global axes. The controls in the Rotate section of the Measurement Axis tab are used for orienting the measurement axis so they coincide with the directions of measurement at each point on the structure. Press one of the Y-axis up or down arrows in the Rotate section of the Measurement Axis tab, and notice how the measurement axes rotate about the Y measurement axis. Press the Reset button to realign the measurement axis with the global axis. 4 different types of animation equations can be created at each point. Translation equations. Examples of translation data are vibration data and acoustic intensity. As many as 3 translation equations can be created at each point, one for each measurement axis direction. Scalar equation. Examples of scalar data are sound pressure level, sound power, temperature, or pressure data. This data is typically animated using color contours on a surface model. Because scalar data has no direction associated with it, only one scalar equation can be created at each point. Machine rotations. Machine rotational data is measured from a rotating shaft. This data is animated by displaying the rigid body rotation of all radial points about a center point. As many as 3 machine rotation equations can be created at each center point, one for each measurement axis direction. FEA rotations. Rotational DOFs are created as part of FEA modal shapes. As many as 3 FEA rotation equations can be created at each point, one for each measurement axis direction. FEA rotation equations are also used to perform structural modifications and FEA model updating using FEA mode shapes. Only translational equations will be used in this tutorial. The Animation Equations tab displays the animation equations for all points on the model. Click on the Animation Equations tab to display the equations for the 4 selected corner points of the car body. Scroll through the animation equations in the spreadsheet on the tab. Point 1 is animated in the Z direction using data from measurement number 2. Point 2 is animated in the Z direction using data from measurement number 1. Point 3 is animated in the Z direction using data from measurement number 4. And point 4 is animated in the Z direction using data from measurement number 3. Notice also that the X and Y directions are interpolated at each point but have no equation, and the scalar equation is not defined. Before animation can take place, measured animation equations must be created for those DOFs on the structure model where measurements were made. Animation equations can be manually entered on the Animation Equations tab, but they can also be created by executing one of the Assign Measurement Number commands, either in the structure window or in one of the animation source windows. The animation source list box is displayed on one of the structure window toolbars. This drop-down list contains the names of all data blocks, shape tables, and acquisition windows that are open in the work area. Any of these files can be chosen as the current animation source for assigning measurement numbers. Notice that the current animation source is the car data block. This is the only animation source window that is open in the work area. The Assign Measurement Numbers command can be executed from any of the following windows: Draw, Assign Measurement Numbers in a structure window; Tools, Assign Measurement Numbers in a data block window; Tools, Assign Measurement Numbers in a shape table window; and Connect to, Assign Measurement Numbers in an acquisition window. The Assign Measurement Numbers command provides 2 methods for creating measured equations. Match point numbers and measurement axis directions on the structure model with DOFs of the measurement numbers in the current animation source. Or graphically select a measurement axis on the structure model and assign a measurement number from the current animation source to it. We will use the first method to recreate the measured animation equations that were already present in the model when the project was opened. To clear all of the current animation equations from the structure model, execute Draw, Animation Equations, Clear All Equations in the structure window, and click on Yes and OK in the dialog boxes that follow. Execute Draw, Animate. You will get an error message telling you that there are no animation equations because they were cleared in the previous step. Before creating new measured equations by matching point numbers and directions with DOFs of measurement numbers, the structure model and current animation source must be set up as follows. 1. Each measurement number in the current animation source must have a DOF containing the point number and direction where the measurement was made on the test article. 2. Each measurement point label on the structure model must be numbered to coincide with the numbers in the DOFs of the measurement numbers in the current animation source. 3. The measurement axis at each measurement point on the structure model must be the same type: rectangular, cylindrical, spherical, or machine, used in the DOFs of the measurement numbers in the current animation source. In addition, the measurement axes must coincide with the actual directions of the measurement. To check the DOFs in the current animation source, execute Window, Arrange, for Animation. Drag the vertical blue splitter bar to the left in the data block window to display the DOFs column in the Traces spreadsheet. To check the numbering of the 4 measured points, execute Display, Point Labels in the Structure window. To check the measurement axes, execute Draw, Animation Equations, Equation Editor, and select the 4 corner points. Having verified that everything is ready for assigning measurement numbers to create new measured equations, execute Draw, Assign Measurement Numbers in the Structure window. An Assignment Methods dialog box will open, allowing you to choose a method for assigning measurement numbers. With Match Structure and Source DOF selected, click on OK in the dialog box. A dialog box will open when the animation equations have been created. Another way of verifying the measured equations is to display the measured DOFs on the model. To display the direction of each measured equation, execute Draw, Animation Equations, Show Measured DOFs. Notice that each measured DOF is indicated on the structure model using a red arrow. There are 2 ways to initiate animation. Execute Draw, Animate in the Structure window, or execute Tools, Animate Shapes in the current animation source window. When animation is initiated, only the points and directions with measured equations will move, unless the Animate interpolation command has been executed. Execute Draw, Animate in the Structure window to initiate sweep animation again using the newly created measured animation equations. Execute Animate, Interpolation to enable interpolation. Press the No button so that no interpolation equations are created. The structure model will again be animated with shape data generated by sweeping the line cursor through the data block traces. But without interpolation equations for all of the unmeasured points and directions, only the 4 measured corner points will animate. During animation, only the points and directions with measured animation equations will be animated unless interpolation is enabled. When interpolation is enabled, all points and directions with interpolated equations will also be animated. Execute Animate, Draw in the Structure window to terminate the animation. Execute Draw, Animation Equations, Interpolate all points. A dialog box will open, allowing you to choose the directions for creating interpolation equations. Click on OK to create equations in all directions. This dialog box allows you to specify the maximum number of geometrically close measured and fixed points that will be used to create each interpolated equation. The structure model has 57 points, and since 4 points have measured equations in the z direction, interpolated equations were created for the remaining 53 points in the z direction. To examine the interpolated equations, execute Draw, Animation Equations, Equation Editor, to display the Equation tab above the Points spreadsheet. Execute Draw, Animation Equations, Show Measured DOFs to turn off the Measured DOFs display. Select an unmeasured point. Click on the Animation Equation tab to display its interpolated equation. The interpolated equation for the selected point is a weighted summation of all four measurement numbers. The closest measured point has the largest weight, while the next closest point has the next largest weight. To verify this, execute Draw, Show Measured DOFs, again to enable the display of measured DOFs. Click on the front corner points to display their measured DOFs. Now the model is ready to animate using both the measured and interpolated equations. Execute Draw, Animate in the Structure window to initiate sweep animation again using the newly created measured and interpolated animation equations. To more clearly view the structural deformation, it is helpful to display the undeformed structure along with the deformed structure. Execute Animate, Deformations, Undeformed to display the undeformed together with the deformed car body. When a data block is chosen as the current animation source, shapes are displayed on a structure model by using trace data at the cursor position. Each measured and interpolated equation defines a shape component for a DOF on the model. Each equation is evaluated to determine the shape component for a DOF using a weighted summation of trace data for each measurement number in the equation. The shape data displayed on the structure model depends on which cursor is displayed in the data block. If the line or peak cursor is displayed, the trace value at the line cursor position or the peak position in the band is used as a component of the displayed shape. If the band cursor is displayed, the trace data in the cursor band is summed together to form each shape component. Three kinds of animation can be used for displaying shapes: sweep, sign dwell, and stationary dwell. Execute each of the Animate, Method commands from the list on the toolbar in the Structure window to observe its animation. During sweep animation, the data block cursor is swept through the traces from left to right. When the cursor reaches the right end of the traces, it starts over at the left end. Sweeping can be initiated from any position on the traces by dragging the cursor in the data block window. Sweep animation is also confined to the displayed samples of trace data. To confine the sweep animation to a portion of the trace samples, execute Display, Zoom in the data block window and draw a zoom box over an area of the trace data. Notice that sweep animation now cycles through only the displayed data. During dwell animation, the cursor will remain in its current position and the shape data is displayed from the current cursor position. During sine dwell animation, each shape component is multiplied by sine wave values that range between -1 and +1. During stationary dwell, the shape values are displayed without any sinusoidal modulation. Drag the line cursor in the data block window to display a different shape. Animation speed is controlled with the Animate, Increase and Decrease Speed commands in the Structure window. These commands are also displayed as a turtle and a rabbit on either side of the current Animate, Method command list on the toolbar. During sweep animation from a data block, animation sweep speed can have values between 0.1 and 15. For a speed of 1, every sample of trace data is displayed during the sweep. For a speed greater than 1, samples of trace data are skipped over. For a speed of 2, every other sample is displayed. For a speed of 3, every third sample is displayed, and so on. For a speed less than 1, the speed is decreased by linearly interpolating between adjacent samples of trace data. For a speed of 0.5, 2 interpolated values are displayed between the adjacent samples. For a speed of 0.33, 3 interpolated values are displayed between adjacent samples, and so on. During sine well animation, animation speed is changed by using a different number of sine wave values per cycle of animation. Sine dwell speeds have values between 1 and 15. For a speed of 1, the maximum number of sine values per cycle is used. For a speed of 15, only 4 sine values per cycle are used. The amplitude of shape animation is influenced by the type of shape scaling you choose, and by using animation amplitude commands or their tools on the toolbar. Regardless of which scaling is used, you can always change the amplitude of deformation or arrows animation by using the animate amplitude commands. The amplitude value can be changed in increments of 1 between 1 and 5, and in increments of 5 above a value of 5. Execute animate, increase amplitude, or animate, decrease amplitude to change the animation amplitude. Execute animate, amplitude to enter an amplitude in the dialog box that opens. The 3 animate step commands are used to pause the animation and step it through its frames. When step is enabled, animation is stopped and the current animation frame is displayed. The step commands are useful for documenting results. Execute animate, next frame, or animate, previous frame to display the next or previous animation frame. Please note animation will remain on step until step is disabled by executing animate step again. During animation, shapes are scaled in one of 3 different ways. Using autoscale, each shape is scaled relative to its own maximum component value. With relative scale, each shape is scaled relative to the maximum component value of all data in the current animation source. With fixed scale, each shape is scaled using a user-defined fixed animation scale factor. When autoscaling is enabled, all shapes will display with the same maximum amplitude regardless of their shape values. Execute animate, method, sine dwell. Execute animate, scaling, autoscale to enable autoscaling. Drag the line cursor to the beginning and then to the end of the data block traces. Notice how the shape animates with the same amplitude from beginning and end of the trace display. When relative scaling is enabled, each shape will display with an amplitude that is relative to the maximum data value in the current animation source. Execute animate, scaling, relative scale to enable relative scaling. Drag the line cursor to the beginning and then to the end of the data block traces. Notice how the shape animates with large amplitude from the beginning and with small amplitude from the end of the trace display. If the measurement numbers in 2 or more animation sources correspond to measurements at the same DOFs on a structure, then animation can be switched from one source to another without stopping the animation. To switch from one animation source to another, click on a data block or acquisition window to animate its data, or click on a shape button in a shape table window to animate its data, or choose a source from the animation source list on the structure window toolbar. To demonstrate animation from two sources, execute help, demos, frequency-based ODS in the ME'scopeVES window. The demo project will open and begin animation. Notice that the project has two animation sources, a data block and a shape table. Right-click on the shape table in the project panel and select Open from the menu to open its window. Execute Window, Arrange for animation to arrange the three windows. Drag the line cursor in the data block window to display its shape. Shapes can be displayed in animation using one of the following methods: deformed, arrows, contour fill, and contour node lines. Deformed animation displays shapes as a deformation at each point. If the structure model contains substructures, then deformed animation will only occur on the substructures with deformation selected in the Animate Using column of the substructure spreadsheet. Double-click on the Animate Using column in the substructure spreadsheet in the Structure window. A dialog box will open. Select Deformation or Both in the dialog box and click on OK. Execute Animate, Deformed to enable or disable the display of shapes as deformations at each point. Animation with arrows displays shapes as an arrow at each point. If the structure model contains substructures, then animation with arrows will only occur on the substructures with arrows selected in the Animate Using column of the substructure spreadsheet. Double-click on the Animate Using column in the substructure spreadsheet in the Structure window. Select Arrows or Both in the dialog box and click on OK. Execute Animate, Arrows to enable or disable the display of shapes using arrows at each point. Contour colors are used to display the magnitude of shape components on structure surfaces. All shape magnitudes within a band of values are displayed using the same color. If the structure model contains substructures, then contour fill will only occur on the surfaces of the substructures where the data type being animated is also selected in the Contours Data Type column of the substructure spreadsheet. Double-click on the Contours Data Type column in the substructure spreadsheet in the Structure window. Select Translation in the dialog box and click on OK. Execute Animate, Contours, Contour Fill to enable or disable the display of shape contour colors on the model surfaces. Contour node lines are lines where the shape magnitude is 0. Contour node lines are displayed on surfaces and have the same requirements as contour fill. Execute Animate, Contours, Contour node lines to enable or disable the display shape contour node lines on the model surfaces. To terminate animation, execute Animate, Draw in the Structure window, or execute Tools, Animate Shape in the Animation Source window. Animation will also be terminated if one of the following occurs. 1. A command is executed that modifies data in the current animation source window, or 2. The current animation source window is closed.